And speaking of the Earth, the moon, and the events on our planet that helped to pave the way for our species to survive, let's talk about a massive, massive story that is happening right now in the world of finding life elsewhere. NASA.gov. Webb discovers methane, carbon dioxide, and atmosphere of K2-18B. A new investigation with NASA's James Webb Space Telescope into K2-18b, an exoplanet 8.6 times as massive as Earth, has revealed the presence of carbon-bearing molecules, including methane and carbon dioxide. Webb's discovery adds to recent studies suggesting that K2-18b could be a Hycean exoplanet, one which has the potential to possess a hydrogen-rich atmosphere and water ocean covered surface. I'll talk about what a Hycean exoplanet is later. The first insight into the atmospheric properties of this habitable zone exoplanet comes from observation with NASA's Hubble Space Telescope, which prompted further studies that have since changed our understanding of this system. So this planet orbits a cool dwarf star, K2-18, in the habitable zone and lies 120 light years from Earth in the constellation Leo. Exoplanets such as K2-18b, which have sizes between those of Earth and Neptune, are unlike anything in our solar system. This lack of equivalent nearby planets means that these sub-Neptunes are poorly understood, and the nature of their atmospheres is a matter of active debate among astronomers. We're not too sure about what's going on here. The suggestion that the sub-Neptune K2-18b could be a Hycean exoplanet is intriguing, as some astronomers believe that these worlds are promising environments to search for evidence for life on exoplanets. Quote, our findings underscore the importance of considering diverse habitable environments in the search for life elsewhere, explained Niku Madhusudan, an astronomer at the University of Cambridge and lead author of the paper announcing these results. Quote, traditionally, the search for life on exoplanets has focused primarily on smaller rocky planets, but the larger Hycean worlds are significantly more conducive to atmospheric observations. The abundance of methane and carbon dioxide and shortage of ammonia support the hypothesis that there may be a water ocean underneath a hydrogen-rich atmosphere. So that would be cool. These initial Webb observations also provided a possible detection of a molecule called dimethyl sulfide. On Earth, this is only produced by life. Let's mink 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 mink. Let's do that again. Let's do that again. Oh, all right, all right, all right, all right. Because I don't. Let's whoop, boop, 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 boop. Let's redo that one. The abundance of methane and carbon dioxide and shortage of ammonia support the hypothesis that there may be a water ocean underneath a hydrogen-rich atmosphere in K2-18b. These initial Webb observations also provided a possible detection of a molecule called dimethyl sulfide. Now, what the hell is dimethyl sulfide? Well, glad you asked. On Earth, this is only produced by life. The bulk of the dimethyl sulfide in Earth's atmosphere is emitted from phytoplankton in marine environments. Let's full stop. Digest that for a second. This is good. This is good. This is promising. 120 light years away in the habitable zone, and there is evidence of a molecule that can only, to our knowledge, only be created by life, mostly by phytoplankton. So we're not talking big giant blue whales where you have millions and billions and trillions of individual cells that make it up. No, we're talking about phytoplankton, very small creatures that are, when compared to a human, not that complicated in their genetic or cell structure. We're not saying that there's these giant sea monsters on this planet. We're saying that there's evidence that there might be some. There might be some. Oh, wow. Wow. And you can see right here the amount of light blocked. You can see the different spectra of K2-18B obtained with Webb's N near infrared imager and slitless spectrograph and near infrared spectrograph display an abundance of methane and carbon dioxide in the exoplanet's atmosphere, as well as a possible, once again, this is possible, detection of a molecule called dimethyl sulfide. So, I mean, I cannot stress this enough. This is a major discovery. It is 2023. And this, up to this point, this is one of the best cases that we have of finding real solid evidence of life. Now, it is possible that there is this molecule in the atmosphere. It's a possibility. So let's keep that in mind. While K2-18B lies in the habitable zone, it is now known to harbor carbon-barren molecules. This does not necessarily mean that the planet can support life. The planet's larger size, with a radius 2.6 times the radius of Earth, means that the planet's interior likely contains a large mantle of high-pressure ice, like Neptune, but with a thinner hydrogen-rich atmosphere and an ocean surface. Haitian worlds are predicted to have oceans of water. However, it is also possible that the ocean is too hot to be habitable or liquid. Interesting to know when we're talking about phytoplankton as well. Characterizing the atmospheres of exoplanets like K2-18B, meaning identifying their gases and physical conditions, is a very active area in astronomy. However, these planets are outshone literally by the glare of their much larger parent stars, which makes exploring exoplanet atmospheres particularly challenging. They're just looking at the light that is going through the atmosphere of this planet, which is 120 light years away. Pretty crazy stuff. This result was only possible because of the extended wavelength range and unprecedented sensitivity of Webb, which enabled robust detection of spectral features with just 2 transits, said the researcher. For comparison, 1 transit observation with Webb provided comparable precision to 8 observatories with Hubble conducted over a few years and in a relatively narrow wavelength range. These results are the product of just 2 observations, with many more on the way. Hopefully we get confirmation. Explained team member Savas Constantino of the University of Cambridge. This means our work here is but an early demonstration of what Webb can observe in habitable zone exoplanets. The team now intends to conduct follow-up research with the telescope's mid-infrared instrument spectrograph to hope they will further validate their findings and provide new insights into the environmental conditions of said planet. Folks, this might be it. We have to do more testing. We have to look more into it. But as we're looking right now, we're looking good. We're looking real good. And now let's talk a little bit more. This is sciencealert.com talking about it. In 2019, it was the first habitable zone rocky world in whose atmosphere's water was detected. So this is something that we have been looking at for a period of time. The habitable zone is the distance from its host star at which liquid water can persist on the surface, not so far as freeze into ice, nor so far that it steams away. Although this is a little bit bigger, there is water on this planet and that oh so lovely dimethyl sulfide. Using JWST's near infrared and near infrared, basically using the JWST, I forget the abbreviations. They watched K2-18B as it orbited between us and its host star twice. Then they studied the difference in the star's light, the result of having traveled through and being changed by the composition of the exoplanet's atmosphere. When they teased apart these changes, the researchers found evidence of carbon molecules, carbon dioxide, and methane. The spectrum of light also revealed hints, but only hints of dimethyl sulfide. So we need to do more findings at this thing. We should be pointing the JWST at this thing 24/7. I mean, the pictures of the galaxies are great. They look beautiful. They're much better looking than previous telescopes that we've had, but if I were running this thing, I'd be looking for life. I want to find life elsewhere out in the universe because I think it is so important. It is one of the most important things in the entire universe to know whether or not we are alone on this planet. Whether there is something that we have to look forward to say we're not alone. We have others out there and we can come together as a community and hopefully make our universe a little bit better. And also, if this life on this other planet is in a very early stage, maybe we can send something from our planet that will maybe get there in hundreds, if not thousands of years, but still get to this planet and hopefully help them on their journey to becoming an intelligent civilization. I hope that we would do that for this planet. Now, let's talk about a Hycean planet, mentioned multiple times as what this particular planet is. So, this is another Science Alert article. This is kind of talking about what a Hycean planet is in and of itself. When we search for life out there in the galaxy, we base our efforts on what we know. So far, we only know that one planet has yielded life, obviously ours. That doesn't mean life doesn't exist on planets less like Earth, though. Now, a team of astronomers has identified a class of planets that may prove fruitful exoplanets clad in a global ocean with atmospheres rich in hydrogen could host life as we know it. Keyword there, as we know it. Such exoplanets are more numerous in planetary surveys than rocky ones, which means they could be fertile territory in the search for alien life. The researchers have dubbed them Hycean worlds. Quote, some of the conditions in the oceans of these worlds could be similar to habitable conditions in Earth's ocean. Similar temperatures and pressures, presence of liquid water, and energy from the star. Astronomer, the same person from Cambridge University Institute of Astronomy told Science Alert. Quote, there are many open questions, but this is only a first guess at this stage. The assumption is that if microbial aquatic life can form into these oceans in the same manner as they did on Earth, then some of the biosignatures may also be common. To date, nearly 4,500 exoplanets have been identified and confirmed out there in the wider Milky Way galaxy. Data from the Kepler Planet Hunting Space Telescope suggests that the most common type of exoplanet is one that we don't even have in the solar system, mini Neptunes, which basically means from 1.6 up to 4 times the radius of Earth. So big boys. These are obviously smaller than our ice giant Neptune, but above the threshold between rocky planets and gaseous ones. This size and composition results in a thick atmosphere rich in hydrogen, like Neptune, and possibly a liquid ocean beneath it. Previous research suggested that the pressure on these worlds would be too high to support life as we know it. But last year, this researcher and colleagues published a paper on mini Neptune K2-18B, as we have talked about. Hycean worlds, the researcher and his team found, can be up to 2.6 times the size of Earth and up to 10 times Earth's mass. They also have a much larger range of distances from their host stars at which life could survive, what we call the habitable zone. Hycean exoplanets can be so close to their star that atmospheric temperatures can reach nearly 200 degrees Celsius or 400 degrees Fahrenheit, or at distances at which a rocky planet would be too icy. The greenhouse warming due to molecular hydrogen is such that the planet can be very far from the star and still have warm, habitable conditions on the surface. For an Earth-like atmosphere, on the other hand, the main greenhouse gases like H2O and CO2 freeze out at shorter distances, making the surface frozen and not habitable. Because of this wide habitable zone, there's a large variety even within the category of Hycean planets. Worlds so close to their stars as to be tidally locked with one side always facing the star, like our moon, would be classed as dark Hycean exoplanets, where life could only survive on the night side away from the heat and radiation. Cold Hycean worlds would be those at higher distances, where they would receive relatively little light, warmth, and radiation. The definition of these parameters means that future work can look at the atmospheres of such worlds to try and identify biosignatures, compounds in the atmosphere that could be signs of life. These include ozone, oxygen, and methane. But on Hycean worlds, which don't have as much atmospheric oxygen, other compounds such as methyl chloride and dimethyl sulfide could signal the presence of life. Essentially, we have been looking for these various molecular signatures. We have been focusing on planets similar to Earth, which is a reasonable place to start. But we think Hycean planets offer a better chance of finding several trace biosignatures. In their paper, the team laid out a few biomarkers that we might expect to see on Hycean worlds. These can be detected when an exoplanet passes between us and its stars, as we discussed before. Because mini Neptunes have such thick atmosphere, this should be easier to accomplish than with the thinner atmosphere of rocky planets. The James Webb Space Telescope will be able to perform this task very well, but several other instruments that are currently operating would be able to perform scouting observations to establish, for example, the presence of water in a mini Neptune atmosphere. Meanwhile, while waiting for telescope time, there's more theoretical work that needs to be undertaken, but it looks promising. And then finally, a potential illustration of what this planet might look like. And then you see the small little dwarf star that it is orbiting around. What is the likelihood of this? What are the chances that this is actually a promising planet? Where even if there isn't humans as we know it walking around on the surface of this planet, maybe there is very small, even single-celled organisms. I think we're getting close to the discovery. And as I've gotten older and I realize the mortality of living, I've thought about it more and more with every passing year. Just life is something that is not common. It's not something that is widely available throughout the universe. It is a privilege. It's something that not a lot of people, one, have access to, but also one that people get to experience, because although I'm here and you're here watching this video right now, there are literally infinite numbers of people who are not able to, because there is currently only one Earth that we know of. Now, with the new evidence and new data that comes out in the future, hopefully we can prove that there are other planets out there which support life. But as it looks right now, we might be alone. Now, with the James Webb Space Telescope, we may find evidence of life. We're not going to find civilizations. That would be very complicated and very hard to do so. But I hope that we're able to find clear signals of life on a planet such as K2-18B. And one of the things I'm going to do today is I'm going to find where this planet is in the night sky and take a couple of minutes tonight. And I do have a telescope, but I might just sit out and kind of look up into the stars tonight and wonder, am I looking back into an expanse of nothingness where I'm the only eyes looking outwards? Or am I looking into a universe with potentially millions, if not billions, of other civilizations looking right back at me? I certainly hope we're not alone. I certainly hope that there are peaceful and loving civilizations that are out there that want truly what I would call the best intentions for our universe. They want to see the expansion and broadening of just doing fun stuff, of being nice to your neighbors, being supportive of those people who may not have given you a good shot in the past. All these things that on a day-to-day basis you may not think about. But whether you think about it or not, these things still happen on a day-to-day basis where you have a small inconvenience, and because you're not thinking about, maybe we're the only ones here, and we should be infinitely grateful that we're here right now, and we should use our time to help make the lives of other people better, to help ease the pain and suffering that happens on this planet. Because as it looks right now, there may not be another civilization out there. And maybe it's us who has to set the example of what it means to be a positive civilization. Maybe we're the ones to set things in motion for our universe. Maybe we're the ones who can finally go to Mars and start a colony on Mars. And maybe this time when we go to Mars, we don't treat it like we have treated Earth in the past, where we pollute our oceans, where we start wars over frivolous reasons, where we make up lies to go into wars and we invade countries and we kill innocent people. I hope that that's not a reality on a different planet. And I hope that that's something that is only here on Earth. Unfortunately, I don't think that's the reality. I think there are other civilizations out there. And unfortunately, I think there are other civilizations that are just as bloodthirsty as us humans are. But with that being said, I certainly hope that much of the conversation that we've had today can change your outlook. And you can be excited that there is this possibility of life elsewhere. And you still have to pay your bills. You still have to go to work. You still have to clock in. You still have kids. You still have chores that you have to do. You have a mortgage to pay off. You have rent to pay. You have student loans that you have to pay. You have a mom who's in the hospital. You have a dad's doing this. You have a brother who's doing this. You have a sister doing this. You have a cousin doing this. All the different factors of life which may affect you negatively. A car crash, a bill that you got all out of a sudden that you can't pay. You can't pay your car on time because you have to buy groceries and the price of groceries has gone up in your area. These are things that not just Americans, but people on this planet deal with. And I can't sit here and say that finding life out in the universe is going to help somebody else out, but I hope it can make you appreciate just even a little bit the luck that we have here on Earth, and that maybe it's not worth it. to curse out that guy who just cut you off in traffic. It's not worth it to be disrespectful to your parents. It's not worth it to get into a fight with your wife over something silly. Like she didn't do the dishes, or she didn't make your food the correct way. She burned your toast or something like that. These little things that irritate you in the moment. You're like, I just came home from working a full day and now I have this thing or that thing that I have to worry about. It is frustrating. But that does not mean that you should disrespect your spouse, disrespect your friends, have these anger spouts with these people that you truly love and care about. Sometimes there are things that are bigger than you. And hopefully, with the hopefully soon discovery of life elsewhere in our universe, hopefully that can open some people's eyes. And I hope that that can help inspire some people to not lead with so much anger and so much angst and so much pain in their lives. It can help people relate with each other, even if they disagree about politics, even if you voted for Biden or you voted for Trump, or you think both of them are war criminals who should be put in prison, or if you think both of them are the greatest presidents that we've ever had. Or you live in a completely different country where conversations like this never come up. There are no conversations about, do you think we're alone in the universe? Because you're working so much, because you have to provide for your family. And unfortunately, it's a sad reality of a planet that not everything or everyone is equal. And now I wish it was different. I wish these massive corporations would provide more for their workers. Not to say that they don't provide anything for their workers, but to help people out. People get taken advantage of all the time. In governments that take advantage of their people, or politicians that take advantage of their people to enrich themselves. I've talked about a couple of times on this podcast about stock trades from politicians in our own United States federal government. And now currently there's another impeachment inquiry about our current president of the United States. And now I'm not an expert on the topic. Yeah, I've talked about some of the stuff that the House GOP has said about Hunter Biden and his business dealings overseas and those different stories. And if you want to see kind of what my take was at the time, maybe now looking back on it, I would have maybe a different opinion on it. But go look back and see what I talked about then. There are so many things to focus on in this planet, and there are so many different ways to be upset and be hurt and be disappointed with our government, with our people, with our species as a total. But I hope that talking about these stories can help bring a sense of hope to people that we are not alone, that there is life elsewhere out in the world, and that we can have an impact on it, that we can spread the best parts of our society out into the universe. Now, it's not for me to decide what are the best parts of our society, but there's a big list of many of those things.